Hi everyone and welcome to this video about inverse functions. Before we begin, remember to like and subscribe if you enjoy the video, and if you have any questions about the content that we cover, or any other maths question, leave it down in the comments section below. An inverse function exists in order to undo whatever has been done by the initial function. We can think about this with a function machine. Let's say our machine first multiplies by 2 and then adds 3. Well, if we place a value x into our machine, after the first box we'll get 2x and finally we'll get 2x plus 3. An inverse function will take the output of my function and return to me the input. So that means if I place in 2x plus 3 into my inverse, the output should be x. Let's see how to do this. In the reverse direction, we consider the opposite of every single step that we've taken. So we're going to think about the opposite of plus 3, that is of course minus 3, and the opposite of timesing by 2 is dividing by 2. We call these inverse operations, and that's what we need to be thinking about when we're calculating the inverse. So if we put in 2x plus 3, we'd first have the 3 subtracted away to leave us with 2x, and then we'd divide 2 by 2 to just leave us with x. In function notation, we would write the first function as f of x equals 2x plus 3, and the way we would write the inverse is f to the minus 1 of x. This power of negative 1 is not here raising f to anything. It's not an index. It's just a way of noting that this is an inverse function. So f to the minus 1 of x, or the inverse of x, so we'll first subtract 3 away from my input and then divide by 2. So here my input is x, that's why I was inputting x there. So if we place x into the function f, we'll output f of x, and if we take f of x and place it into the function f to the minus 1 of x, we'll end up with x again. On a graph, this looks like a reflection in the line y equals x. One way of thinking about this is that the x is the input, the y is the output. So a reflection in this line switches the inputs and the outputs. So let's say I start with the line f of x equals x minus 1. I'm going to reflect that line in the line y equals x. I'll end up with f to the minus 1 of x, or the inverse of f of x, which here will be x plus 1. This is very obviously true because the inverse of subtracting away 1 from a number is just to add 1 back again. So now we're going to look at an algebraic method to find the inverse function. If we were to just use those function boxes from before or the graph, we wouldn't be able to do complicated functions. We're going to start with this simple example, and I'm going to lay out the steps that you need to follow. The first step is to take our function and replace the side with f of x, or whatever your function is notated as, with y. So we take y and set it equal to 2x minus 5. The next step is to make x the subject of our equation. So I'm going to add 5 on both sides, and then divide both sides by 2. So now I've made x the subject of the equation, it's time for the final step. Now when we're writing functions, the convention is to take our function and represent an arbitrary number with x inside the input bracket. So now I'm wanting to calculate the inverse function. I would like to still have x inside my bracket to show me how to apply the function. So the final step is to look at my rearranged equation, find the side that contains y, and replace all of those y's with x, or whatever input you so choose for your inverse function. In this case, I still want x as my input variable for f to the minus 1, so I'm going to replace all of my y's with x. And this here is how to find the inverse function. So writing my final answer up above, f to the minus 1 of x is x plus 5 over 2. We can always test if we found the correct inverse by putting a set of numbers through both functions. Let's take the value x equals 5. So putting 5 into f of x, I get 2 times 5 minus 5, which is 5. That means I'm going to take my 5 now, put it through my inverse function, so f to the minus 1 of 5 is going to be 5 plus 5 over 2, or 10 over 2, which gives me my initial input of 5. Let's work through another example together. Step number 1 is to set the function equal to y. Step number 2 is to make x the subject of the equation. So I subtract 2 from both sides, times both sides by x, and divide both sides by the bracket y minus 2. And the final step is to replace my y with my input value, which I'm going to want as x. So my inverse function, when I place x as my input value, is going to be 3 over x minus 2. Let's go through another example. I'll go through this one a little bit quicker. So we set y equal to our function. I'm going to rearrange and make x the subject of the equation, timesing both sides by 4 minus x, expanding the bracket, rearranging to get x on the same side, factorizing out the x, dividing both sides by the bracket 2 plus y. The final step is to rewrite it in the correct notation. I want f to the minus 1 of x, so I'm going to replace those y's with x. And there's my final answer. Let's look at a final example together. In order to solve this function equation, I'm first going to need to find the inverse of f. So setting our function equal to y, and rearranging to make x the subject of the equation, dividing both sides by y, and rewriting our inverse in the correct notation. Now I can move on to the section where I'm solving my equation. So I set 3 over x plus 2 equal to 3 minus 2x over x. Timesing both sides by the denominators, we get 3x equals brackets, 3 minus 2x, close brackets, times by the bracket x plus 2. Let's expand and solve this, rearranging and making the quadratic equal to 0, simplifying on both sides, factorizing, and finding our two solutions, which are x equals minus 3 and x equals 1. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.